Riemann integration. So, before I define Riemann integration, I talk little about the inspiration of the idea Riemann got, the new type of integration which is named Riemann integration. Actually, where we use this, sometimes the region enclosed by a function is not regular, and it is not regular. I am using here mean like the shape not in the rectangular. If we have a region bounded by the rectangle, then easily we know how we can find the area of this figure. If this is B, the breadth, and this is L, then area, we know the area of a rectangle is given by L into B, length into breadth. But if the figure is somewhat difficult, suppose we have to find area of the figure, suppose something like this. Then in this case, how we can find the area? Because if I make square, then there will be error, because this area, this part, I denote this area which will produce the error. This area will be the error. So how we can get rid of this error? This idea was given by Riemann, and even in villages, in our villages, if you talk to the mason, because many a time they encounter the problem, the area, how to calculate area of a plot if the plot is not in the rectangular shape. Then what they do, what the village mason or the farmers, how they calculate area, but maybe it is not very corrected. They divide this area in the rectangular. That means to calculate this type of area, how we can do? If I make the whole square, then this error is very much. So we can make it small rectangle. Like I can make this rectangle. So what happened? Now only, that means if I make a small rectangle, then you can see our error is up to much extent is reduced. That means now the error is now you can see how much the error. This red, this is the error. That means if I make this shape, then error is this white part also included. And if I divide the small rectangle and I calculate the area of each rectangle and sum the area of each rectangle, then our error is much reduced. But as if I reduce the size of the rectangle, then more error can be reduced. So this is the idea of the Riemann. So Riemann says what? If we have to find area of a region enclosed by a curve or a function which is not straight or not regular, in that case we divide the region in the small rectangles and then we can find it. So simply I take a example. Suppose I say this is a figure AB, and I am asked to calculate the area, that means this area. Then if I say one thing, I need to know what is this function, and if I take this function y is equal to x, then if I make one complete rectangle like this, then this is the error, and this error is very much, it is almost double. So I divide in small rectangles. Suppose I divide this much rectangle, then you see this area, this now the error is this, I am making it red, this is the error. So you see, if I make the big rectangle, then error was very much, and if I make the size of the rectangle is small, then you see error is reduced. More small rectangle I make, more error I can reduce. So now I come to the definition first. Riemann integration is saying let f be a function defined on interval AB is said to be Riemann integrable if limit n approach to infinity of the upper sum fp, where f is the function and p is the partition which we discussed, and this exists. If the limit of the upper sum over the partition p of the function f exists, then we say function is Riemann integrable. Now, what is upper sum? That means u f p. So here f is the function and p is the partition. We discussed those things. This I can write equal to sum of supremum of f t, the maximum value of f in interval xi, where del xi is equal to xi plus 1 minus xi plus 1 minus xi. So this thing we need to understand what is the supremum of the function. And one more thing, what is this t? T is some element where function has the maximum value in the subinterval xi to xi plus 1. T is the point in the subinterval xi to xi plus 1 where function has the supremum value. That means this is the product of, product of supremum of ft into length of the subinterval xi plus 1. So we need to understand this. Like, for example, if I draw the graph like this was, and this is, I take the subinterval xi to xi plus 1, then what is the maximum value of f? Obviously, in this case, this point is the maximum value or the supremum value of the function. But it can change. If our graph is like this, then this point is the supremum value. That means this is ft. So t is somewhere here. So this is the maximum value. And length of this, that means what I get, what is this? In this interval, if I say this is the y coordinate and this is the length, that means this become the rectangle, So here error is this part. So this becomes the rectangle supremum of ft into length of the interval is del xi. Del xi is where del xi is equal to xi plus 1 minus xi. So now this is the supremum part I explained. Now one more thing here is the partition. Partition is simply, you say, the part. I make the part of an interval. So first we learn how to make part of an interval. Suppose this is interval A and B. So length of the whole interval, that means L of interval AB is B minus A. Length of this interval is B minus A. If I divide this interval in n part, suppose 1, 2, 3, 4, like this, 4, sorry. Okay, these are n part. This is, I say, x1, x2, x3, and this is xn minus 1, and this is equal to xn, and this I take x0. So length of, if they are equal part, then what is the length of xi plus 1, that is xi plus 1 minus xi, and this is equal to b minus a divided by n. That means one question simply I say if I have interval, this is 1 and this is suppose 2. So length of the interval 1 and 2 is equal to 2 minus 1, that is 1, and divide, suppose this is in 3 equal part. If I divide the interval 1, 2 in 3 equal parts, then length of each part is 1 by 3. That means if I say this is 1, this is 2. So this 1 part, this is 2 part, this is 3rd part. So length of this whole interval is 2 minus 1, and length of any of these 3 parts, this part is 1 by 3. This is equal to 1. Or if I divide it in 4 parts, if I divide in 5 equal parts, then length will change 1 by 5, and see what the scenario now become. Our interval is 1, 2, then the length of whole interval is 2 minus 1 is equal to 1, 1, 2, 3, 4, 1, 2, 3, 4, 5. So length of any of the interval, that means this length is 1 by 5. This also 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 1 by 5. If I add them, then it becomes 1. See, 1, 2, 3, 4, 5. That means this is 1 by 5 plus 1 by 5 plus 1 by 5 plus 1 by 5 plus 1 by 5. This is 1. That means, so similarly, if I say it is, okay, one more thing I tell you. So each part become of length 1 by 5. So if I say find the coordinate of this point, this is 1. So this, what is the coordinate of this? 1 plus 1 by 5, and this 1 plus 2 by 5, and this is 1 plus 3 by 5. This is 1 plus 4 by 5, and this is 1 plus 5 by 5, that is equal to 2. That means in 1 I add, because the length of this part is 1 by 5. If I add 1 by 5 in 1, I get 1 plus 1 by 5. Now it is the double of this, that means 1 plus 2 by 5. Similarly, 1 plus 3 by 5. This is 1 plus 4 by 5, and this is 1 plus 5 by 5. This is 2. So this is how we understand the geometry of the partition. So what is P? P is the set which contains the point x naught, which is equal to a, x1, x2, x3, and last is xn equal to b, where AB is the interval. So this is the partition, or you can say P is the collection of the subinterval xi plus 1, where I varies from 0 to n. So this is partition. Now I ask you the question. Suppose we take a very simple question first. Okay, I all rub this so that we can use the space. If I am asked find the Riemann integration of, I am just direct doing, of fx equal to x on interval 0 to 1 by dividing 3 equal parts. So here we are given this is 0, interval is 0 to 1, and dividing this in 3 equal parts. So I divide 1, 2. So what is this point? The length of the whole interval we know 1 by 3, because so L of length of 0, 1 is equal to 1 minus 0, that is 1, and length of subinterval is 1 by 3, because I am dividing it 1/3. So simply this is the length 1, and length of this part is 1 by 3, this part also 1 by 3, this part also 1 by 3. So coordinate of this point we can calculate. It is 0 plus 1 by 3, that is 1 by 3, and this, because it is double, so 0 plus 2 by 3, and this is 0 plus 3 by 3, that is, I can say 3 by 3 equal to 1. Now our function is given this. This is our fx is equal to x. So I divide three rectangles, so one rectangle is this, one is this, and one is this. So maximum value of f in this rectangle is 1 by 3. That means I can simply say what is the coordinate of this point. Because y is equal to x and x is 1 by 3, so this point, the 1 by 3, x also 1 by 3. Similarly, coordinate of this point is 2 by 3, comma 2 by 3, and coordinate of this point is, you can say 1, 1. Now area of this rectangle. So I calculate UPF. Simply you can say UFP. That is sigma supremum of Ft into del xi. So the maximum value of f in this rectangle is 1 by 3. That is 1 by 3 into what is the length of the interval? That is also 1 by 3. Similarly, in this rectangle, the maximum value of f is 2 by 3. Now, length of this interval, del xi, this is again 1 by 3 plus, in this rectangle, maximum value of the function is 1, and length of, that means this length is 1 by 3. So if I calculate 1 by 3, I can take common. This remain 1 by 3 plus 2 by 3 plus this I can write 3 by 3. So this is 1 plus 2, 3 plus 3, 6. 1 by 3 into 6 by 3, that is 6 by 9, that is 2 by 3. Now, if I calculate, so what is the error? Simply you can see the error, because the actual area is the triangle, the simple integral 0 to 1 fx dx, and fx is equal to x 0 to 1 dx, that is x square by 2, limit 0 to 1, that is 1 by 2. So this is 1 by 2 actual area, and by Riemann we get this. So the error is 2 by 3 minus 1 by 2, this is equal to 6, 4, 3, that is 1 by 6. So our answer is, in our answer there is some error.